Hey there, Marcus McDaniel again here for week 11 reading. This week in week 11 we learned about modeling friction, we went over collisions, and we also went about conservation, um, specifically conservation of momentum. So we were kind of involving these momentum vectors and their initial vectors, their initial momentum versus their final momentum of two objects after they collide, and then determining their final momentum after the collision. Um, some of the stuff that I learned during this week was, I wrote it down here, was said perpendicular to displacement, the forces don't do any work. So the displacement was, obviously the distance between the 2 points that you're referring to, and then any force that was perpendicular to that displacement did not do any work. So we went over friction and how friction dissipates energy. So an example that was given was when you're pushing a box, you can feel the heat. Heat should be present because the box is slowing down due to the friction. And this heating up is, it's almost like slowing down the box, because then it's dissipating the energy from pushing it, which then eventually causes it to slow down and then come to a complete stop. We were using delta E with delta K trans and delta E thermal, which was equal to work again. So that was one of the more past knowledge topics, I would say, was still using energy and still using work. So in that section was a little bit more for review, just since we've been going over it a lot in the last couple weeks. And also another topic that was more of a review was the reciprocity, when we were adding the forces when they were interacting between each other. So we had F on 2 by 1 and F on 1 by 2. Those two could then almost cancel out, and so we were left with just the forces from the surroundings. But yeah, and so then we also had to go over elastic and inelastic collisions. This was kind of a big part. So inelastic was when K final did not equal K initial, as where elastic was when delta K was equal to 0. And so in some of the videos, in the last two videos, it was all about just collisions in one dimension. So they were giving us a bunch of examples where these two balls were hitting each other, and either going in the same direction or bouncing off in different directions. So our job was to be able to determine what was the final momentum of, let's say the second ball. And so one of the key tips was that, and so when you have the momentums, you have the total momentum, and then you have momentum of 1 plus the momentum of 2. And so momentum of 1 and 2 can change, but the total must stay the same. So for example, if you had momentum of P1 equal to 1600, and the momentum of P2 as 300, that means your total is 1900. That's your vector. And so no matter what, so if I had, say, now my new P1 was 1400, since that's able to change, the total is not able to change. So 1400 plus P2 must equal 1900, which is how we can determine it being equal to 500. So that was one of the main tips that I kind of got out of this. In terms of difficulty, maybe the determining whether it's inelastic or elastic, given the formula. I know the formula, we can just plug in the numbers, but sometimes I might just get a little mixed up along the way, so just going through that video again would help. Doing a couple practice problems, maybe the homework might have something as well. So that's definitely a good place to go if you're having trouble with that. If you're having trouble with other stuff as well, YouTube again would be a very good place to go, study and review these topics and get a better understanding. But yeah, overall, so learning conservation of momentum, we're learning how to use the second law explicitly. So yeah, Newton's second law is still hanging around. I feel like that's going to hang around the whole time, so that's always review. But yeah, so now we're just learning about collisions in one dimension, and we'll just see how it progresses in next week and later in this week.